So this is section 7.2. And last time we started with the basic graph of sine and cosine, just the basic period of 2 pi. We talked about how it repeats itself. And so today we're going to kind of extend that. We're going to talk about how can we take that basic graph and adjust it a little bit. Okay, so the standard form of a trig function, and when I say a trig function, I'm talking sine or cosine. The standard form would be y equals, and I'm going to say a, and I could use either sine or cosine, so I'm going to use sine. A times the sine of b, in parentheses, x plus or minus c, close parentheses, plus or minus d. All right, so I'm going to say this is the standard form, and basically those A, B, C, D numbers, those are the places where you can have different numbers. There might be a number in the very front where A is. There might be a number right here in front of the parenthesis. X is a variable, so that's an X. It could be a plus or minus, and then C is some number, and then D over here is some number. So for all I know, maybe the equation is y equals 2 sine of 3, and then in parentheses x plus, usually, we'll talk about this later, but usually the C number, it's a number, but usually it's in terms of pi. So maybe it's a pi over 2 or a pi over 3 or a 5 pi, but pi over 2 is still a number. And then you might have, let's say, minus 5. So those are all the different places you could have numbers in a trig function, and each of those numbers tells us something different about the graph. And basically, that's what we're going to go through in the next 2 or 3 sections. Okay, but for today, we're going to focus just on the A number. All right, so we're going to focus just on the A number. Right there, A. So notice number 1 says use your calculator to graph y equals sine. Well, you know what? I don't need my calculator to graph y equals sine. I know what y equals sine is going to look like. Remember how we said it starts, it ends, and halfway at 0, and we said it goes up to 1 and then down to -1. So I can draw the basic sine function. Okay, let's see if I can draw it better. I can draw the basic sine function right there. I don't need the calculator to help me with that. All right. But then it says, hey, also draw, notice there's a number in front of the sine right there. It says draw 2 sine of x. Okay. And then it says, hey, draw another one, graph 3 sine of x, all on that same window. So I'm going to show you what happens. What would you suspect that A number is going to do? So I'm going to go ahead and put in the original sine function since they told me to. So here's the sine of x. And then down here I'm going to put 2 times the sine of x, 2 times the sine of x. And then down here I'm going to put, what do we have here, 3 times the sine of x. I'm just curious, since I have blue on the sine of x, I'm trying to get it to match what I have on the screen, and I have red on the 2 sine. I wonder if, does this have green? I bet it doesn't. I'm just going to try it. Let's see, can I get green? Ooh, magenta. I don't want that. What other colors? Oh, there we go, green. Okay, so now, boom. So now the colors on my calculator are going to match the colors that I have on my screen. All right, so first it's going to graph sine, then it's going to graph 2 sine, then it's going to graph 3 sine. And remember we said we're going to go from 0 to 2 pi. Okay, everything else is set. So there we go. Sine, 2 sine, 3 sine. Boom. What happens? Okay, just looking at this screen, notice the zeros are all the same. Every single graph goes through the same zeros. In fact, the only thing different is going to be that high point and that low point. Where the normal sine only goes up to 1, notice the red one went up to 2 and the green one went up to 3. Hope you're noticing that. And the same thing, where the original sine went down to -1, the red one went down to -2 and the green one went down to -3. Hopefully you're noticing the pattern there. So here's my 2 sine. The zeros were the same, but instead of going up to 1, it went up to 2. Instead of going down to -1, it went down to -2. So there's my 2 sine. And then the green one, remember, the zeros were still the same, But instead of going up to 1, it went up to 3. Instead of going down to -1, it went down to -3. So something like that. Okay, let's pretend like I can actually draw this decently. I'll get better as we go. Okay, so just to kind of label, the green one, remember, was 3 sine. And the red one, remember, was 2 sine. And the blue one was just the basic sine of x. And if you think about it, what number is in front of that sine? Isn't there an implied 1? So notice what that number in front does. It just changes the max and min. It does not change the zeros. Okay, so let's see. What can we put here? It says in standard form, meaning if it's set up like we were talking about up there. So I'll say y equals a sine b x plus or minus c plus or minus d. The a, remember for today we're talking about the a. The a is the amplitude. We call it the amplitude. Hopefully that's easy to remember, a for amplitude. And it represents what we call a vertical stretch. A vertical stretch. Okay? And let me show you what I mean by that. You don't have to draw this. Let me just show you. If I were to take the basic sine function, right? Starts, ends, halfway, up to 1, down to -1. If I were to take this basic sine function, okay, if I were to stretch it out, in other words, if I were to grab the top and grab the bottom and just start pulling it apart, right, stretching it vertically, it would look like this, right? If I were to just start stretching it vertically, it would look something like this. Now let me get rid of this thing. If I were to take that and move it back kind of down to where the original was, do you see how it just looks like I stretched it out? Or you could say, hey, what if I want to shrink it up really flat? It's the same basic shape. Again, it's the same basic shape. It's just that you can either squeeze it up or stretch it out. So we call it a vertical stretch. Okay. So let's go to number 2. It says use a calculator, but you know what? I don't think we need a calculator. It says use your calculator to graph y equals 2 sine of x. Okay, I'm going to start with y equals 2 sine of x. I already know what's going to happen. I know it's going to start, end, and halfway at 0. And because the amplitude is 2, I know it's going to be stretched up to 2 and stretched down to -2. So there is my sine function. Okay, but what do you think this negative is going to do? Well, think about it. I mean, we've done graphing before, and we've said, what's the difference between having a negative in front or not? Think about parabolas. If there's a negative in front of your x squared, what did that do to the graph? Didn't it just flip it over, flip it across the x-axis? Well, the same thing is true. I mean, I can put this in my calculator, but I can tell you right now what it's going to look like. It's still going to start, end, and halfway at 0, but instead of starting up, it's going to start down, because if I were to just flip this whole thing across the x-axis, it's going to come down first and then go up. So does this graph look like the exact same shape but just flipped across the x-axis? Okay, so in standard form, y equals a sine b x plus or minus c plus or minus d. When the a is negative, so let's kind of highlight here. If a is negative, then the graph flips across the x-axis. Okay, so without using your calculator, could you graph 3 sine and -3 sine? Okay, I know 3 sine starts, ends, halfway at 0. Since the amplitude is 3, that means it goes up to 3, down to -3. So there's my 3 sine. and then -3. The zeros are still going to stay the same, right? Start, end, and halfway at 0. But instead of starting by going up, it's going to start by going down because it's flipped across the x-axis. So there is my -3. So this is -3. And remember, this one was the +3. Okay? What about if the amplitude is 1/2? Same thing is true. So the zeros stay the same, start, end, halfway, but where the normal sign goes up to 1, if my amplitude is only 1/2, then that means I don't go up to 1, I only go up to 1/2. And instead of going down to -1, I only go down to -1/2. So it's still the same basic shape, it's just kind of squeezed up, right, or squished in a little bit. So the same thing with negative, let's see, that was 1/2 sine of x. So with the negative, again, the zeros stay the same, start, end, halfway, but instead of going up, I'm going to start by going down, but I'm only going down to -1/2 and then up to +1/2. So it's the same basic shape, it's just flipped across the x-axis. Okay? So, what about cosine? All right, think about the basic cosine. We learned this in 7.1. What do I know about the basic cosine? I know it starts and ends at 1. Halfway, I'm down at -1, and then halfway between each of those is the zeros. Remember, they kind of look like a V. And remember how we said make sure you curve through the ends. Okay, so that is the basic cosine. So if the amplitude doesn't change the zeros, if what it changes is the maxes and mins, then instead of starting and ending at 1, I'm going to start and end at 2. And instead of halfway being -1, it's going to be -2. But again, the zeros don't change because the amplitude does not change the zeros. So here's my cosine graph. 2 cosine. So let's try this. It says, what about -2 cosine? Okay, well, so if I'm flipping it across, instead of starting up at the +2, I'm starting down at the -2 because it needs to look like it's been flipped across the x-axis. Instead of the halfway being up at +1, it's going to be up at +2. The zeros don't change, so make sure you curve through those endpoints. So this is going to be -2 cosine. Okay, what about -1/2? I think this is supposed to be -1/2 cosine. I'm going to change this to say -1/2 cosine. Sorry about that. Okay, so for -1/2 cosine, again, where normally cosine starts and ends at 1, because I'm flipping it, it's going to start and end negative. What is it? What negative? It's going to start and end at -1/2. Halfway, instead of going up to 1, I'm going to go up to only a half. The zeros don't change. So again, it's the same basic shape. It's just squeezed up a bit. Okay? So again, like before, the 7.2 homework practice, I mean, we've done all of these, but it's just you getting used to the idea of having an amplitude and drawing the basic sine and cosine graph, and then possibly flipping it across the x-axis. So it's just a little practice with the same stuff. These are all no calculator because this is you getting used to being able to draw it without using your calculator.